Welcome. So let's do some more derivatives of inverse trig functions. I don't think I have room to write the formulas, but I think we'll be okay without the formulas. Because we reviewed those in the last video. We've got two challenge problems, finding the antiderivative. We'll do the derivatives first and we'll do those last. All right, so we want to find the derivative of arcsecant of 3 natural log of x. Of course, we need to find the derivative of the inside. The derivative of 3 natural log of x is going to be 3 divided by x. So our derivative, dy dx, is 3 over x divided by the absolute value of 3 natural log of x times the square root of 3 natural log of x squared minus 1. Right? Here, the absolute value bars really aren't all that important because natural log has got to be positive all the time, but we will just leave those in. All right, so now, first of all, we're going to square, and second of all, we're going to simplify that complex fraction. So we're going to have to multiply every term in the numerator and denominator by x. Well, technically, we only have one term in the denominator because they're multiplied, right? We have this times that. So we only need 1x. 1x will do it. All right, so now these x's will cancel, and so that will look a whole lot nicer. Notice that x is now just in the denominator. So our final answer, because we'll square at the same time, is dy dx equals 3 divided by x, absolute value of 3 natural log of x, times the square root of 9 natural log of x minus 1. All right, you have a product there, you just square the terms. All right, so now let's look at the second one. All right, so we need to take the derivative of 3x squared, which of course is 6x. So dy dx is 6x, and then using our formula, oh, love that line there, is this, that just looks so bad. Even the eraser, you can see it. I'm going to write it over here, and I'm going to move it up. The square root, oh, and don't forget our negative. Right, because our cosine is negative, so negative 6x over the square root of 1 minus 6x all squared. Now, and I guess it's going to come in pieces. And we'll simplify that. Hopefully it writes better down here. dy dx equals negative 6x divided by, not much, the square root of 1 minus 36x squared. And there we go. Let's do the next. Let's do number 10. All right, so this is just like tangent, except it's negative. And we are not going to forget the negative. All right, so we need the derivative, first of all, of the negative x. And of course, that's just negative 1 using the power rule. So guess what? Our negatives are going to cancel out. So we have dy dx equals negative 1 divided by 1 plus negative x all squared. All right, we'll simplify that. So dy dx equals 1 divided by 1 plus x squared. Look at that. Now it's just like arctangent, right? So when we took the derivative of negative x, of arctangent negative x, we got the same as the derivative of arctangent for just x. Isn't that interesting? And it may be that they are just shifts of one another, right? All right, so let's find the derivative of arcsecant. All right, well, we just did the derivative. Hey, wait a second. That is exactly the same. Repeat. And you can say I didn't make this, so it was a worksheet in 7 and 12, exact same answers. All right, let's go to the antiderivatives. All right, let's look at the first one. And do you know that there's the chain that hangs down from my ceiling is blocking? Okay, that's a 5. I couldn't see the numerator. All right, so we want to find the antiderivative of f prime of x equals 5 divided by the square root of 1 minus 25x squared. So we're going the other way. We're saying, who has that derivative? All right, well, look how it's written. All right, notice you got the square root of 1 minus something. That looks like it might be arc sine. All right, so if we had, so here we have 25x squared. If we take the derivative, the square root of 25x squared, that would equal 5x. And what if we took the derivative of 5x? Well, we would get 5. Notice we have 5 in the numerator, the derivative of 5x. Notice we have 25x squared in the denominator, 5x squared. Guess whose derivative that is? That is. So our function is f of x equals, so I squeeze it in. I think I'm going to have to move it to the bottom here. I don't think it's going to make it. Arc sine of 5x. There we go. That wasn't too bad now, was it? All right, now let's look at the antiderivative of negative 6x squared over 1 plus 4x to the 6. We don't have any radicals there. And I see squared things. I see 1 plus a squared thing. It's making me think arc cotangent or arc tangent. It's negative. It's making me think arc cotangent. Let's check this out. All right, so if we take the square root of 4x to the 6, that would give us 2x cubed. If we take the derivative of 2x cubed, that would give us 6x squared. Notice that we have this 2x cubed squared in the denominator. We have 6x, the derivative of 2x, let's try that again. We have 2x cubed squared in the denominator. We have the derivative of 2x cubed in the numerator. And it's negative. All right? So that matches the formula. I have a lot of space here. I'll write the formula. That matches the formula for the derivative of arc cotangent. Right, which is negative f prime of x over 1 plus f of x all squared. All right, so this is, so f of x, so the function who has that as a derivative is f of x equals arc cotangent of 2x cubed. And there we go. And we could check that. We could have checked the other one as well. We could, let's check it. All right, so let's take we took the derivative. Here's our little check. All right, then we would have the derivative 2x cubed. That would be 6x squared over, and it would be negative, right, because this is our cotangent, over 1 plus 2x cubed all squared. All right, so that would give us f prime of x equals negative 6x squared divided by 1 plus 4x to the 6, which is exactly what we have. All right, so we figured it out. All right, I'm going to pause this tape and I'll meet you in the next video to do the rest of this lesson. Thanks for watching. Bye for now.